Pretty good. Yeah, I'm still just hung up on that line, seeming to kind of split quit into quit 0 and quit 1.
Yeah, sorry about that one. That should not have happened. At some point, I guess I left an old code in there. Because quit is the target variable, it should not be one hot encoded. It should just be turned to a categorical variable.
So is there a way to kind of exclude that from the PD get dummies?
Yep. How did I do that? What did I do wrong there? It should have been excluded. Is anybody off the top of their head, when you do a PD get dummies, how to exclude a specific column?
Which column did you have to exclude?
The dependent variable, target feature quit.
Oh, why don't you just delete that column?
So here's where we are.
I usually just do df.pop, then parenthesis quote quit. Then you can just pass that into a variable. Then that's your label, pretty much.
df.pop.
Also just pop it out.
Yeah. Was anyone able to get the model at all?
For me,
If not, I can just share the model really quick and we can just get started.
yeah, Wenchen, can we do that? Can we use the model?
That's fine. I'll just share the model I trained really quick. Okay. I pickled the model, obviously. So let's get started since we're on time. And I'm still debugging a little bit, but I was able to get the Flask app running, and it's saying the health is good. So I'm good on that. The final error, I think the error I have currently is the integers 64 is not JSON serializable. So I need to basically convert that data type back to JSON serializable integer, which is just integer in Python. Okay, so let's get started. So what I quickly did was I basically took the preprocessed data and loaded in. What I did was I log the monthly hours just so we can have the normal distribution, and then we have the we just basically quickly checking the data set percentage. I don't think I did it weights, which I should have done. So I'll probably improvise on that once I'm committing right before I'm committing my code. So we should absolutely do that. and I train test splits 10%, and pop the target variable, then pass that into a variable called train label, validation label, test label, and you numpy array the rest of your data frame without the label, pretty much. And then I have a standard scalar. I fit transform everything and collect the features as well. So every step of those needs to be in the pipeline, right? Remember we talked about the pipeline previously. So if you recall the last workshop we had, it needs to be basically modularized and pipelined through this. So hopefully in the next workshop or the next couple workshops, we can get this into a format like this for a different for this particular data set, HR data sets, or whatever data set you want to work on. So back to this, and then I just feed that into an XGB classifier. I was using the cross-validation to get some ideas. Then eventually I just wanted to grid search, and I find basically 100 trees and one scale position weight. I believe that was the best out of every. Yeah, so I was able to get AOC ROC AUC of 98.99. But again, the real score might be a little lower depending on the weights that we're gonna have. So right now we have, so I basically just feed that parameter into that and just fitting on that and joblib.dump, dumping that. And I was able to predict and get a list of predictions or array of predictions pretty much. And that's the model that you guys are looking at right here. So obviously, as we have learned, we need to version that. That's the timestamp. Okay, so that is what we got from the human resource prediction. So, and obviously, that's not the focus for this session. The focus is this. So what you want to do is you want to set up a project folder and have a top package name as HR Prediction API. And we have the Flask. Oops. And we have the, I have the IPy kernel, but you don't have to. I have the pandas, numpy, XGBoost. Make sure you install XGBoost here as well. And we have two, one as get methods, and we have one as post methods, which is the predict method, obviously. And, we talked about the setup.py. You can do this and deploy HRX classifier, and and this way it's just easier, and it becomes a package. So, and you have your venv virtual environment, and I'm still writing the testing code, obviously, but once this is done, what you need to do is basically say app.run and specify a port, and make sure you're loading your model, right here, and then you can check. Well, I guess you can load your model here as well, and check your model to see if your model is there, and get the JSON from the post method. And so I'm using p.readJSON, and then you predict on that pretty much. Then you JSONify the prediction results, and you can have a debug equals true if it's in development mode. If it's in production mode, just debug equals to false. That should be it. Now, what you have is so let me just do this for you guys. So sorry, too much Django. Python manage.py. All right, Python main.py. And that would basically run through this min.py, and it would just basically run through the app.run. And so right now, this should say this site cannot be reached. And if I start the Flask app, and it will warn you saying this is a development server, do not use it in a production development, and your debug is active, you're running on 127.0.0.1 port 8080, because we specify the port at 8080. And we're direct, if we go to this, it will say not found, because we didn't specify just a slash. You know what I'm saying? Like if we have a slash here, meaning we have an app.routes as slash and without the health, then it will show up. It will show something up here. And if you want to have, actually a website, you might want to have, say, some HTML codes right here, right? And but right now we don't have anything. We're just like health status okay. So that means, hey, this is being hosted locally. And if we have the predict, we'll say method not allowed. Method is not allowed because we're trying to get the get method on the predict, which only allows the post method specified here. And the way how you can test it is, you can test it with something like Postman, or just like request, right? You can just request that and request a post to see if you can post that file JSON. That's in a nutshell of how you can serve your model with Flask. And again, Flask is very, very lightweight, right? So all you are doing is app equals to Flask name, and name is basically main.py. And then you're just specifying, two methods with a decorator app.route. One is predict, one is health, and then just app.run. That's it. That's how simple this is. So any questions? And what you need to do is basically host this app on AWS or host it somewhere, then expose this, this endpoint to the public or to some IP, whatever, or authenticate it, whatever it is. Any question? What's that?
Most companies that have this, they will have a standard way to deploy apps, whether they use a service or that's based on Heroku or something. You'll have something available, right? Doesn't have, most practitioners won't just be creating Flask apps, bottom line.
Yeah. Smaller companies might, use that, but at a bigger shop, you probably want something like, just TFX. And with regarding to like, scikit-learn, you might just want to use SageMaker pipeline, that is something that you can certainly start using, or Airflow, right? Which is open source. This, I guess, is not open sourced, as it would have to somehow, I think, it probably would have to ask you to utilize SageMaker platform. It's a tool for building machine learning pipelines that take advantage of direct SageMaker integration. Yeah, so it will allow you to train on SageMaker. It has a SageMaker Studio integration. And data lineage tracking. Yeah. Cool. So now I'm probably going to end early, but we got two options here. Right now, we can talk more about a more advanced version of this API, or you guys can spend another half an hour continuing to work on this and create a folder like this, right? And have your app, your Flask app built up. So continuing on your own journey of building this quick app with the model I just gave you, or we could basically go into this. So we're going to talk about how a fully fledged API is done, at a more advanced level. I mean, I guess with regarding to the app itself, it's not as advanced, but it also incorporates components like validation, schema validation, and how you can validate inputs, and and you're not and with this, you're not saving the model itself. You're actually saving the entire pipeline, so that when you have your so that's how you actually make sure your training pipeline and inference pipeline are aligned. It's because you're saving the entire pipeline as using joblib. So if you're looking at save pipeline, so that's you're saving the entire pipeline and just joblib.dump. Once you're done training, you're just calling that save pipeline and save that entire pipeline when you're done training. And then you load the entire pipeline with joblib.load. So what do you folks want to do?
If no one else has any ideas, would love to walk through the scikit-learn pipelines.
Oh, this one?
Mm-hmm.
Okay, so let's walk through this more advanced version of it, and you folks can keep working on this HR data set if you choose to, and get to the level. At least you can host your Flask app, and maybe you can work through this error that I had. I'm certainly this is not pretty bad. This is not a bad error. Or terrible error to solve at all. I think you just pretty much need to integer or convert the data types, which I did not do. And again, that's where the input validation would come in, right? Fields.integer. This is actually pretty handy library. It's called Marshmallow. So once you validate all the inputs, then basically I think JSON should be fine. then you shouldn't have this error. All right, so let's walk through this. Let me share this repo again. I think we talked about, yes. Just so everyone has this repo. Okay, I just shared the GitHub link, and feel free to just clone down this repo, and we can walk through that. So previously, we talked about the regression model package, right? And now we're going to talk about the ML API package. Now, as I initially said, what you want to do is separate these two packages. And what they have chosen to do is to actually put two packages within one GitHub folder. That is a practice that I don't personally prefer. I rather separate them out. But obviously there's some merits, and even some of the Google repos would have multiple packages in them. And I think they're called monorepo, something like that. But it makes the folder structure like pretty complex, and especially the regression. So each of the package would have its own, like, so the setup.py no longer sits within this folder. It sits underneath the package itself, and its own each of the package has its own requirements.txt, and each of the package itself has its own version file as well, and it has its own logs, configs. So you're basically grouping two packages into one, top level folder. Then you just have like Docker file, readme, Docker ignore, git ignore files. Docker ignore is basically just ignoring the files to copy into Docker container when you compile the image. It's basically like git ignore, but except you're just, when you, it's not dealing with Git, it's dealing with Docker. When you're compiling the Docker image, you need to, copy, paste a bunch of files from your local folder into the Docker container. And that's when you can choose to ignore, let's say virtual environment folder, bunch of other folders. Then you don't want to be copied into the Docker container. So, okay. So what happens here is you have an API right here, okay, and you have three folders. You have API folder, logs folder, tests folder, and requirements.txt, and you have a run.py, which is this application.run. But it basically just imports the development config and create app, api.app, which is right here, and it basically, it's further modularized, I guess, rather than something like what we had here, which is just a main.py and just app.run. I guess it's further modularized. This is a Flask app. We're returning the Flask app. And just Flask app.run, right? Instead of app.run, we're just like Flask app.run, because that returns the Flask app anyway. So, and I was just digging more into logging and setting different levels of logging for projects this week. And how many of you are familiar with logging? Just
I
type in the
could.
chat.
Mhm.
Great, awesome. So several of you are familiar with logging. That's great. So for those of you who, okay, a little bit, thank you. So what happens is in the production environment, you don't want to use a lot of print statements, and because print statements is cumbersome, it's not as Pythonic, and it doesn't give you it should give you uh, whereas logging would give you tiers of information, right? So it gives you 5 tiers, all the way from debugging to info and to warning and to like error to critical. So in each tier of log would basically get, tell users, hey, if it's a critical error, that would probably stop the app even from running. And um, and if it's debug level, that means it's probably just some information that helps you to debug. If it's just info level, it just gives you info, right? It just confirms something. So those are not like actually very important, or I shouldn't say important, but those are all important, I guess. But like, it's not preventing you from running your app. It's not like very critical stuff, right? But and look at what and you can set different files can have their own loggers, and and also you can output the logging logs into a log file such as this, right? So I mean, it's empty here, but you can have a log folder to specifically store all the logs, and you can specify, hey, if it's a warning or above, log that into the ML API.log. So that's how logging works. And in the production environment, you do want to try to set up your logging instead of just printing a bunch of stuff. And in this way, when other people, or other teams are using your apps, they know exactly, hey, is that a debug level, statement, or is that a critical level statement? And also, you can set up formats as well. You can have the timestamp of that log set up, and you can set a bunch of stuff. You can even set, basically send all the logs into your email as well, or Slack app, whatever you want to do. It's a very, very important step when you try to productionize your project. Okay, so and that is in combination with PyTest. So and that's another topic that we could spend a little time talking about, but we will dig more into that, I think, towards the end of the 5 series talk of scikit-learn model pipeline. And we'll dig more into that, and even get more hands on those logging and testing. So, but right now, let's just focus on this. So this is just creating an app, and we're just debugging. We're just saying this is application instance created, and that information is to help us to debug. So that's at a debug level of logging. Okay, so, and we have underneath the API folder, we have the app.py, we have the config. Okay, so debug equals to false, testing equals, so we have a bunch of configurations. This is configuring the logging module. So we are setting the logging level at info. So anything above info would be basically let's see, get file handler. Okay, so anything above info, if it's passed in with the file handler, it will be outputted into a file. So anything after that, so if it's info, if it's critical, if it's warning, if it's error, they will all be outputted into a separate file. And you have the stream handler. So stream handler just means it prints on the console. So you can print on the console, and you can, output the logging information to a separate file, and you can do both at the same time. Okay, so controller is where we specify all the Flask app functions. Again, we're basically getting a logger itself for the controller.py, as that would just be the controller.py file. So you want to make sure each file is getting its own logger, so that different files don't get cross-logged. Okay, and you have and you have the health, which is what I had as well. Health status okay. So I had this as well, and we're logging this at an info level, saying the health status is okay. And you might want to have a timestamp and be like, well, I guess you don't have to add it here, because you can just pretty much, yes. So we have a formatter here. So the logging, all the logs will follow this format. It will always have a timestamp following the ASC time format, and we'll always have a name. We'll always have a level name, which is info, critical, warning, debug, whatever, and the func name, and the line number, and the message itself. Okay, that's the format of the log. And we have a version path or route, and what it does is, and it's also get method. If it's a get method, you want to validate your method as well. Then you JSONify and return the model version and API version. So that's for getting the version. Okay, and you can think about other get methods or post methods. And the difference between get method is and post method is, the post method is you're giving something to the web app, expecting the web app to return something, right? And in the prediction scenario, you are providing the web app the input data, and you're getting some data in return, which is our prediction results from the model, right? And that's why it's called post method. But if it's a get method, you're not giving the web app anything. You're just only receiving from the web app, which is the health status right here, and also the versions right here. Is that clear? Any questions? Okay, good. And you can, this is the way of creating, this is the validation.py, and we're basically doing all the validation steps right here. And that's how you handle the validation in production environment. you can customize your own exception by inheriting the exception class. And then you can call this invalid input error, which was not existing previously. And you can pretty much just call this and be like, hey, if invalid input error happens, then I need something, else done. Okay, so those are the fields. If you recall the data set that we were using, this is the housing Ohio Ames, Iowa data set for real estate sales price prediction. And look at how many fields you have to validate. And unfortunately, that's just how it works in real world. You have to validate every single field. If you have 300 fields, I don't know if there's a better way to do this, but I think there were about 80 plus columns for this data set. So you literally have to validate each of them just so nothing is going wrong and it doesn't, throw your model off. So pretty much every single field needs to be validated. Okay, and it needs to say, hey, is allow none equals to true. So if it's allow none equals true, that means you can allow the NANs to go in. So if it's not, then it has to have a value. And it has to match the data type. Okay, so we got alley, bedroom, above grades, building type, basement condition, basement, bunch of basement fields, central, air condition, fence, fireplace, garage, bunch of garage fields, heating, zoning, lot, area, open porch, pool area. Mesh just went through housing purchase. Mesh, I'm sure you're quite familiar with some of this.
Yes, but ignore them. At the end of the day, when you're buying something, you can't quantify your forever home.
Yeah. And I think pool size matters a little bit. It does not matter a lot, but it does matter a little bit. Yeah. Cool. So filter error rows, validated inputs. So this is basically saying, hey, delete them in reverse order so that you don't throw off the subsequent. Remove input data rows with errors. So anything that doesn't pass this validation is thrown off. It's a delete statement right here. Okay, so yes, right here. So if errors comes from exec message, and so okay, so this is basically where you define the schema, and you're like schema equals to, so you're instantiating that class and calling all the input validation from the Marshmallow library, yes, so this is the thing. So when you develop data input fields, make sure your column names don't have like numbers at the beginning, and beginning with numbers. So I think the Ames Iowa data set has like, column names that have numbers at the beginning, which would throw off some of the input validation. So they're basically switching the columns back and stuff. So, and this is probably not a good way to do this because dict is actually a function. I mean, even though this is a dummy variable, but I think you still shouldn't do that, to be honest. Yeah, because dict in Python is a function to start a dictionary. So, all right. So, and when you load the input data, if there are any errors, we'll just give you the error message. And if errors equals to true, you would validate every single one of them. If not, then validated input equals to input data. So that means input data is fine. And you pass in the errors and you validate input data. And if there are errors, .keys, indexes. So based on the index, you delete the validating, you delete the inputs, basically. Then you return the validated input and errors. So that, in a nutshell, that's how you kind of validate your inputs. Okay, and this is where you, well, the question is, okay, where do you actually validate your inputs? You do that right here. So this is underneath the regression model and predict.py. You basically, you can validate right here underneath the make prediction methods. And as soon as you're reading the input data as a data frame and you validate it right away, then you call the pipeline to predict. Then you numpy exponentiate the prediction because it was logged. So you're basically exponentiated back to the price point. Then you have your results. Then you return your results, and you have a info level logging right here, making prediction with model version this, inputs this, predictions that. Okay, and where do you call this make prediction? Back to the ML API controller right here, make prediction. So when you call the make prediction, it's already calling the validation.py, right? And the validate inputs function within this make prediction function. Okay, so when someone hits this endpoint and we're telling them it's V1, we're predicting it, and it's a regression model. Okay, and we need to validate again the request.method. If it's equal to post, great, proceed forwards, and let's get the JSON from the post, the data that's inputted, extract post data from request body as JSON. And you log that as a debug because, you know, if you don't even get the JSON, you should know that. And that's why it's debug, right? If it's not working, if you're not getting the JSON file, then the debug level logging should catch that. Okay, so step 2, validate the input using Marshmallow schema. So basically, we're validating inputs here as well. But I guess the make prediction, under predict is calling this as well. So we're kind of sort of double validating here. I don't know if that's a good thing, but it might not hurt if you do this. And you might want to validate it also on the front end as well. I think we talked a little bit about that, not just on the back end, because this is sitting on the back end. But also on the front end, when someone is inputting something, your front end code should be, you should regulate a little bit on the front end as well, basically. And you call the make prediction, and you get the results. Again, that's a debug level logging, and you get the prediction into a list, and you get the version, and you JSONify that, and you return the predictions and versions and errors. So that's pretty much the predict method underneath this. So the developers of this repo only wrote three API methods: health, version, predict. And obviously you can write more than just that. And I'm sure there's other stuff you can write and develop on top of these three basic methods. Okay, so, and then you can just run the app, right? And then it will just basically return the same message that we have here, serving the Flask app, and then it's running locally. And then you can host this app again on AWS or GCP, however you want to do it. We also have some PyTest stuff as well. Oops. You have the test controller, test validation, conf test. Now, this actually does not go into all this other codes. What you do is you use PyTest to run through these test files. And of course, you are also using PyTest to write these functions as well. For this, you're testing the client, yield test client, create app with app.app context, yield app, test controller. This is basically saying, hey, if I get this health, is that returning status code 200? So for me, it was returning 200. But for predict, it was returning 405 because I was trying to use get methods, right? Get method to a post method only predict function. Of course, I would get 405. So you're testing, hey, is that status code 200? It is, great. If not, it doesn't pass the test. Okay, and it uses assert statements, okay, to test it. Test version endpoints, getting the version, is that matching the version that we have internally? Is that matching the API version we have internally? So it needs to match this file, and needs to match this file underneath regression model and underneath ML API. And it needs to test prediction endpoint returns prediction. So basically, it needs to have some sort of, so you can loading the testing data file, and it's a CSV, and you can do it basically post JSON, and the records in the orient equals to records, and Flask test client post this, and JSON equals to JSON loads post to JSON. And it needs to return status code 200 again, right? That means it's successfully run. And math.ceiling. So basically, the price level shouldn't drop below 112,000. I believe that's what it is. So basically, your prediction shouldn't. Yeah. So the prediction shouldn't drop. I forgot what this means. Why is it 112,476? Okay, but basically it's checking, a number. It's using math.ceiling. Let me just double check what math.ceiling does. Ceiling Python. Math.ceiling return the ceiling smallest integer greater than or equal to. Yes, so it should be smaller. Smallest integer should be greater than or equal to this. Okay, and meaning like your price prediction should be greater or equal to this. And you should have a version tested as well. So obviously you can write more tests, right? And that's pretty preliminary testing, but essential testing certainly. And you have test validation. You can test this as well. This is basically given load the test data from. It's important as it makes it harder for the test data versions to get confused by not spreading it across packages. Okay, so this is basically loading your test data and doing the same thing and check correct number of errors removed. So there are different ways to write tests, obviously. And a lot of times, testing codes tell something about your project, like how well it has been tested, how it basically, and testing is something that gets integrated into a CI/CD pipeline. So whenever you change something, update something, your CI/CD pipeline, continuous integration, continuous development pipeline should run through the PyTest and these three test.py files, and they should all check and without returning error. Otherwise, the CI/CD pipeline would just stop, and you would have to fix the error. And until these go through, these assert statements and test functions go through. And after you're done with that, the CI/CD pipeline should push your latest code to the production code base, and it gets served, right? That's pretty much it. Any questions? Anyone?
Devanjay, is it possible to use scikit-learn model with TFX? Haven't looked into it.
I doubt that's possible. Yeah, because TFX utilizes a lot of things like metadata, and it requires a lot of TensorFlow stuff. So I wouldn't. Yeah, no, I don't think it's possible. But again, I would not, stop you yourself from using other pipeline tools like Airflow, which we will talk about. So
I think even MLflow works with second if I
yeah, Airflow, MLflow, and also, you know, I would check out SageMaker pipeline as well. Yeah, this book it talks about SageMaker pipelines. So I would, yeah, I would dig into this this one, chapter 10 of data science on AWS.
Okay.
Yeah.
The authors of this particular book do a presentation about 4 hours or so or more every month. Previous presentations are already on YouTube, so you can watch last month's or so. And there are upcoming presentations where they'll be doing it live as well. Pretty much everything building up to the pipelines, etc., on AWS.
I think it's part of the AWS channel itself, right? On YouTube.
Yeah.
Yeah.
Thank you.
Yeah. So yes. So and that workshop is pretty good. I think Mash and I both sign up for that workshop, and I believe it's on Saturday.
It's coming up. Yeah, I think so.
Yeah. Let me check when next. Yes, it's actually this coming Saturday on Juneteenth, and so. Yeah, June 19th, and from 11 a.m. EST to, so it's actually a 6-hour workshop.
Yeah.
If I'm not wrong, it is a long workshop, but it seems to be a very good one. But at least this is a very good book. It is written by AWS professionals, but it's pretty damn good. You know, I would say like, you know, tutorials of combining different AWS tools. It literally incorporates like 80 plus AWS tools in this book, and with pretty good quality production level code and projects and tech stacks, obviously. Yeah. So I would check into this if you're trying to use scikit-learn, and so yeah. Someone else. Yes. Thank you, Mesh, for posting that. Yes. If you're interested, certainly attend that workshop. I might attend it as well from this workshop recording. Yes. They have a YouTube channel, and I think they're based. They have a meetup channel as well, meetup.com, from San Francisco. Okay. Any other questions? So we hopefully we can get to, you know, we can, you know, work on this more and get this somewhere, right? And with this HR data sets, and I just need to spend a little time debugging this, but we're pretty close. And of course, you know, add the pipeline components of the scikit-learn pipeline and validate your data. So those are all things you can, you know, pretty much add on top of this, well, on the separate files, but underneath, you know, perhaps underneath this, I would create another folder and just call it validation or something. Any other questions? So next week we are back to TFX, and we're getting closer to the pipeline orchestration. And right after that, oh, we're deploying this on AWS. So with this, we're gonna basically, what we're gonna do is basically upload this model to AWS and just serve it with SageMaker. And instead of creating your own Flask app and REST API, we're going to use AWS gateway, API gateway. And so use API gateway and Lambda to trigger your model hosted on SageMaker. So that is another way of serving and hosting your model. Okay, so then we're going to talk about pipeline orchestration, and we have a TFX workshop right after that. So that gives us more time to play around with Airflow and Kubeflow pipelines. So not just talking about it, but actually, doing it like what we're doing today. Literally giving you folks time to play around the pipeline yourself, so that you can, spend some time with it rather than just only listening to someone talking, because it's always helpful to be more interactive when it comes to learning. So pipeline orchestration with Airflow. So we want to try to do something with Airflow as well, and we're going to talk more about testing, logging, and CI/CD pipeline with Scikit-learn. Okay, that's pretty much it. We're on time, 11:30. I thought we were gonna end earlier, but I guess not. But we're right on time, so that's good.
Swan Chang.
Yep. Any other comments, thoughts before we end?
Yeah, so the notebook which Matt shared, it was very extensive. So you guys put a lot of work to to basically implement that. Yeah, thanks for sharing that.
Yeah, absolutely. And I'll try to commit these two projects on my laptop ASAP as well. Might not be tonight because it's getting late, but certainly tomorrow I'll try best to commit the code to the GitHub as well. So.
And Terrence, to answer your question on the message board, that is correct. It does show up. There seems to be some discrepancy here. The meetup points to Monday, June 28th. However, on my calendar, I am registered for Saturday, June 19th.
Yeah.
So I need to see if they change the times or something. So it'll probably be an email. But follow along with this link. And if you dig through it, you'll see Chris Fregley, who works at AWS and the author of that book, co-author of that book. He does these events every month or so. Even if you can't attend that event, the 4+ hour recording is posted on YouTube. I think there were a couple of versions of it that I saw.
Yeah.
I think, and Pradeep shared it.
Yep.
Okay, great. Thank you.
Yeah. All right, folks. Thank you so much. Really appreciate it. I guess we'll see you folks next week. Have a good night.
Everybody.
Bye-bye, guys.